Hi everybody, it's Mr. H here. Today we're going to talk about the properties of circles. Up to this point, we've just talked about straight lines and finding the equations of straight lines or points on those lines or intersections of those lines. The property of a circle seems like something completely different, but as we're going to find, it's very much related to one of the equations that we've used in the past. If I was to ask you what a circle is, what would you tell me? Some people would say it's a round thing, but how does that distinguish it from something that's three-dimensional? And so you say, oh, it's a two-dimensional round thing. Well, could you not have a round thing that's kind of oval as well, like that? Well, the actual definition of a circle is this, and it's important to keep this in mind. It's the collection of all points equidistant, when you put those two words together, equidistant, from a given point. So if we have this given point, you take all the points that are equal distance from that point. I haven't drawn them all, but if we draw a bunch of those points like that, we can see that if we were to put all the points in between as well, what we would have is we would have a circle. They're all equal distance from that point in the middle. In other words, all the points represent from the middle the radius of that circle. Consider the equation x squared plus y squared equals 25. This is actually the equation of a circle. But let me actually prove that to you and show you why that works. Let's consider a few things. If we let, what we want to do here is we want to find what the y value is when x is each of the following values for this equation. So if x is 5, let's just sub this in here. We get 5 squared. We're going to solve for y. So we get 5 squared plus y squared equals 25. So that gives me 25 plus y squared equals 25. Well, if I subtract 25 from both sides, I see that y squared is equal to 0, which means when you take the square root of 0, it's just 0. And so I'm going to plot that point on this graph here. When x is 5, so here's 5 on the graph, y is 0. So that's a point right there. What about when x is 4? Well, when x is 4, if I sub that in the equation, I get 4 squared plus y squared is equal to 25. Now 4 squared is 16. And then if I go ahead and I subtract 16 from both sides, I get y squared equals 9. Now some of you might say, well, that means that y is equal to 3. Well, think about that. Y could be positive 3, because positive 3 squared equals 9, but it could also be negative 3, because negative 3 all squared also equals 9. So we need to make sure that in equations like this, when you're solving a variable squared, you take the positive and negative of the square root of what you're trying to find. So in this case, it's either plus or minus 3. So let's go and label those 2 points on the graph now. So in this case, I have the point when x is 4, y is positive 3. And here's positive 3 right there. And when x is 4, it's also negative 3. There's that point right there. If I continue that pattern, and I'm going to now substitute in x equals 3, 3 squared plus y squared equals 25. I shouldn't subtract yet. I'm getting ahead of myself. I'm going to go 9 plus y squared equals 25. And if you subtract 9 from both sides, I know that 9 is a little long. I apologize about that. There we go. 9 minus 9, that's going to cancel off the left side. That's going to give me y squared equals, on the right side, 25 minus 9 is 16. And I have to do the same thing as I did before. I have to take the positive and negative square root, because both 4 squared and negative 4 squared would give me 16. So that gives me y is equal to, or this is just y at that point, y is equal to the square root plus or minus the square root of 16, which is plus or minus 4. So now I go and I graph those points. That is x is 3, y is positive 4, or negative 4. So we actually get 2 points from that. Now we can continue that for x equals 2, x equals 1, and I think you're starting to see the pattern of how this emerges. But let's also do, just to finish this up, x equals 0. So we get 0 squared plus y squared equals 25, which means that y squared is equal to 25, which means that y is equal to the positive and negative of the square root of 25, or plus or minus 5. In other words, when x is 0, y is positive 5, and y is negative 5. And so if I continue that same pattern, what you see is on the other side, if I was to use negative 3, negative 4, negative 5 as the x values, I'd get these points right here. And what I'd find is I'd have a circle. All these points are on that circle. And so if I were to graph a line through those points, it would look something like this. So you can see there, that's a circle that passes through all those points. Now notice I put this at -6 and I just moved that up to -5, but it's all these points are 5 units away from the origin. Interesting, look at this equation and just see if you can make some comparisons here between 5 and that 25. That's the next question that we're after. You'll notice that if we take that 25 and we take the square root of it, that equals 5. So in other words, this is the value that it is equal to, whatever x squared plus y squared is equal to, this value is the radius squared, right? Because if you go the opposite direction of the square root, you square it, right? So it's x squared plus y squared is the radius squared. Well, where does that equation come from beyond just empirically finding it out through that data? Let's look at this next proof. Yes, I know I said the word proof. You don't need to fear. It's fairly straightforward here. I have 1 point, 0, 0. So I have a circle centered at the origin. And I have another point on that circle, call it x and y. And so we know the distance formula between any 2 points is always x2 minus x1 squared plus y2 minus y1 squared, the square root of all of that. Now if I take my first point as 0, 0, I can sub those in as 0 and 0. And I take any other point, x, y, on that circle, I can sub that in as just x and y in general. Now what I can do is x minus 0 is just x, and y minus 0 is just y. So I get x squared minus y squared under the square root. And then in order to get rid of the square root, I can square both sides. And when I square both sides, now I get r squared equals x squared plus y squared. And that's the equation for a circle. You might want to put a big box around that. That's the equation for a circle. Oftentimes we'll see it written as x squared plus y squared equals r squared. Same thing. So we're going to go over 4 quick examples together. The first one says this. Determine the equation of a circle centered at the origin, not origin, with a radius of 7 over 3. Well, we just said that x squared plus y squared is equal to r squared. If the radius is 7 over 3, then I just substitute this in. 7 over 3, but I have to square that because it's the radius squared. Well, 7 squared is 49, 3 squared is 9, and so x squared plus y squared equals 49 over 9. That is the equation for that circle. Well, it didn't ask us to do this, but I just want to do a quick sketch so we can see what this physically looks like. 7 over 3 is the same thing. 7 over 3 is equal to 2 1/3. So if I graph a circle of radius 2 1/3, I'm going to just do that by indicating the 2 1/3 on each of the axes. There's my x, y, negative x, and negative y axes. Then I'm just going to draw a circle between those numbers on each of the axes. Now you can do this very accurately with a compass. One of those things that has a needle on one end and you can put the pencil on the other and then twist it around in a circle. And that's going to give that to you. But this is exactly what this circle looks like. Not exactly because I haven't done it with a compass, but it's what that circle radius is. The second example says determine the equation of a circle centered at the origin that passes through the point 12, -7. What is the radius of this circle? Well, let's just be clear here. Every point is x and then y. And so in this particular case, all I'm going to do is I'm going to take the equation x squared plus y squared equals r squared. We have no idea what the radius is. So in order to figure out the radius, if we know the x and y values and we sub those in and we simplify this, we can solve for the radius. So if I sub in 12 for x, I get 12 all squared plus 7 all squared. It's -7. If it was +7, it would still give me the same result because it's squared. And that's equal to r squared. So 12 squared is 144 plus 49. And 144 plus 49 is 193. And so we conclude we'd want the exact radius, that the radius is the square root of 193. Now here you might be thinking, but Mr. Hamilton, earlier you said that when I solve for the x or y value, and it's something squared equals a number, I have to take the positive and negative square root. However, this is radius. Can radius ever be negative? No, you can't have a negative radius circle. So it has to be positive because radius only makes sense if it's positive. So that's the radius of that. And so determine the equation for the circle. Well, if r squared is 193, the radius is root 193, then we could say the equation is equal to x, well, not equal to, it's x squared plus y squared is equal to 193, the r squared term. And then the radius itself is equal to the square root of 193. So what I recognize is the square root of 193 is about 13.9, which is a little bit beyond what I have on these axes. But what I've done is I've just drawn that circle of radius 13.9. I'm choosing positive 13.9 on the x and y axes, negative 13.9 on the negative x and negative y axes. And you'll notice it kind of looks like an oval, and that's simply because the x-axis is stretched a little more than the y-axis is. But that's the equation, that's the graph of the line x squared plus y squared equals 193. The next question says, determine whether the point -3, -5 is on, inside, or outside the circle defined by x squared plus y squared equals 34. Well, if r squared is equal to 34, that means that the radius is the square root of 34, and the square root of 34 is approximately equal to 5.83. It would be a good first step just to graph that circle of radius 5.83, see if you get the same circle that I do. So that's what the circle looks like for that x squared plus y squared equals 34. And then we're trying to find out if the point -3, -5, which is down here, -3, -5, is it on the circle, is it just outside, or is it just inside the circle? And so you might look at that and say, well, it looks like it's just outside the circle. Well, you know what? Looks can be deceiving. We've learned that a number of times in math. So we need to actually do a calculation to know for sure whether we're right or not. So -3, -5, just like we did in the last question, are the x and y values, and we're going to solve for r. So we're going to sub this in, and we're going to solve for r, or the r squared value. So in this case, I'm going to say, because x squared, so -3 squared, and y is -5 squared is equal to r squared. So you notice I'm not solving for the circle. I'm not assuming that it's 34. I'm trying to solve for what the r value is and compare it with the equation for x squared plus y squared equals 34. So this gives me 9 plus 25 equals r squared, and we get 9 plus 25 is 34. Well, if r squared is 34, this value is the same value as this value, or the radius is the square root of 34, and we would conclude, therefore, since these are the same, therefore, -3, -5 is on the circle. Notice that it's also centered at the origin. All these circles that we're doing are centered at the origin, but it's important just to note that. If the r squared value was a little bit bigger than 34, we would say it's outside the circle. If it was a little bit smaller than 34, we would say it's inside the circle. So that's how we would do that comparison. The next example says, find the circumference and area of the circle x squared plus y squared equals 25. We've drawn that before on the previous page, so I'm going to just quickly do that. At first glance, this might seem to be a little weird that they're asking this, but it's actually easier than you might think. Because of this, we know right away that because r squared is 25, the square root of 25 is what r is equal to, and r is clearly equal to 5. Well, how do we find the circumference and area? Well, the circumference is 2 pi r, and the area of a circle is pi r squared. So with those values, I can just sub them in. 2 pi times the radius is 5. The exact answer would be 10 pi. The approximate answer would be, because pi is 3.14, so approximately equal to 31.4. And the area, pi times 5 squared, will give you 25 pi, which is approximately equal to, it's approximately equal to 78.5. Now, we should note here that circumference is always in whatever the units are, not squared. And then in the case of the area, it's 78.5 units squared. And I'll come back and look at the properties of circles to wrap up this lesson.